In Deriver's Exam Review Part 7, Problem 24, we have a logarithm problem, but our inside function is a little crazy. So we're going to use some laws of logarithms to help us to make this problem a little bit easier. So we learned in Algebra 2 that our exponent here can be moved out in front. Let's rewrite this then as f of x is equal to tan 3x natural log x. Sometimes we do algebra to make the calculus easier. Now we have f prime of x is equal to, this is a product rule problem, so remember we're going to do the first function, tan 3x, multiplied by the derivative of the second function, 1 over x, plus our second function, natural log x, multiplied by the derivative of our first function, which is chain rule, so secant squared 3x times 3. We could clean that up a little bit. F prime of x is equal to tan 3x over x plus 3 natural log x secant squared 3x. AP might make a common denominator here. If they do, if I want to put an x down there, I need to multiply by an x up top. So I could have a final answer of f prime of x is equal to tan 3x plus 3x natural log x secant squared 3x all over x. In 25, we have a chain rule problem, inside function natural log. So we have dy dx is equal to derivative of sine is cosine. Don't change the inside. We're going to multiply that by the derivative of natural log, which is 1 over x, or we could just put the x on the bottom. In problem 26, we have a product rule with two chain rules. We have f and g, so remember, dy dx, we need to do the first function, which would be x squared plus 1 cubed, multiply by the derivative of the second function, 5, 4x plus 3 to the 4th power times 4, plus the second function, 4x plus 3 to the 5th times the derivative of the first function, which would be 3x squared plus 1 squared times 2x. We could do a little factoring in this problem to simplify. AP would probably do that. So let's see what we have in common. We have an x squared plus 1 cubed and an x squared plus 1 squared. So we could take out an x squared plus 1 squared. We have a 4x plus 3 to the 4th and a 4x plus 3 to the 5th. We could take out a 4x plus 3 to the 4th power. We could, since we have a 4 here and a 2 back there, we could take out a 2 as well. So now on the inside, let's see what we have left over. We're going to need one more x squared plus 1. We already have the 4x plus 3 to the 4th power. We took out a 2 here, so we're going to need a 10 that we're going to multiply by. Plus, now our second part, looks like we're going to need one more 4x plus 3, so we're going to need a 4x plus 3. We already have our x squared plus 1 squared. We already took out the 2, so we are going to need a 3x on the back side. It's possible that AP would continue to reduce. Let's look at the inside and see if that makes it any better. If I distribute my 10, I get a 10x squared plus 10. If I distribute my 3x, I get plus 12x squared plus 9x. So they could write the inside as 22x squared plus 9x plus 10, and then we could go ahead and put our 2x squared plus 1 squared, 4x plus 3 to the 4th is equal to dy dx. In problem 27, chain rule with e, inside function is tan x, f prime of x is equal to derivative of the outside, don't change the inside, multiplied by the derivative of tangent, which is secant squared.